Hello everyone, welcome to another session of Schneider Electric PLC training tutorial where we shall learn Schneider Electric PLC programming. So let's see what we shall cover in this presentation. In this presentation, we are going to cover the shift and rotate logic instructions or operations. So we'll see what the shift right, shift left, rotate right and rotate left operation do. We are going to begin with the shift right operation. And how does the shift right operation functions? So the shift right operation shifts the data at the input to the right by n number of places. So it actually does bit by bit shift n places to the right. Let's demonstrate this with an example. So as an example, we have this data. Let's suppose we have this data at the input, that is hexadecimal D3, which corresponds to binary 1101 0011. And we want to shift it to the right by 2 places. Okay. So this is our data. This way we have no shift has occurred here. Our data is still 1101 0011. Now let's suppose that after a shift, that is when a pulse comes here, when a pulse comes on this enable pin, okay, for every pulse on this pin, this enable pin, the data will be shifted n number of places to the right. Okay, so let's say that we have now have a pulse here. Now let's suppose that there is a pulse here. So when a pulse comes, what happens is that this data, since we are shifting 2 places to the right, this data will be shifted 2 places to the right. So this data moves here, this data moves here, this data moves here, this data moves here, this one moves here, and this moves there. Okay, and the extreme bits are filled with zeros, okay, because the data vanishes. So this is going to vanish, okay, and the empty spaces will be filled with zeros. After the second shift, what happens now after the second shift? After the second shift, this data now moves here, this data moves here. Remember, we are doing 2-bit shift, okay. This data moves here, this data moves here, and the upper bits are filled with 0. So this 0 vanishes. For the third shift, this will move here, this will move there, okay, and the upper bits are filled with 0. And after that, so you can see that after the third shift, okay, the data, all the data will vanish and everything becomes 0 0. So this is an example, okay, where we are using a pulse of 5 seconds delay to shift the bit. Okay, we are going to look at it in the simulation. So here, when a pulse comes, the pulse will go up. So after 5 seconds, the pulse will go low, and the bit will be shifted. After 5 seconds, the pulse goes low, the bit will be shifted after 5 seconds, and so on. Now let's look at the shift left operation. So the shift left operation is an exact opposite of the shift right operation. Okay, in this case, we are shifting the bit to the left. Okay, so when a pulse comes here, so we have a pulse here, let's say a high, a 0 to high pulse. When it comes there, then the data will be shifted to the left by this number of places. So you specify the number of places that you want to shift the input bits. So you can see here after the first shift, so here no shift has occurred. After the first shift, you can now notice that this data, okay, this data has been shifted 2 places to the right, 2 places to the left, 2 places to the left. This data has been shifted 2 places to the left, 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 and this data vanishes. Okay, so these two most significant ones vanishes, and the least bit positions are filled with zeros. And after the second shift, what happens is that this data now moves here, this data moves here, this data now comes here, this data moves here, and the significant bit is filled with 0 because this is shifted here and this is shifted there. Okay. And similarly, after the third shift, this data now will move here, this data moves here, this data moves here, this data moves here, this one moves here, and this moves here, and the least positions are filled with 0. And after that, the data vanishes. So as we are shifting data the data is vanishing, and at some moment we are going to have 0 0 all true. Okay, so we can use a shift operation to transfer a data. So we can use it to transfer a data from one point to another. Okay, so this is an example also where we are using a timer to left shift the operations. We are going to understand it in the logic when we perform a demonstration. Now we have the rotate right. So the rotate right, it rotates the data. Okay, so here we are performing some kind of rotation. So it rotates the data. Okay, so the data is just like the data is constantly being plowed back. The least significant data for the shift right becomes the most significant data at some point. So here the rotate instruction is used to rotate the content of a data at the input by bit by n places to the right and assigns the result to the output. Okay, so here you specify the number of places or the number of bit shift that you want to carry out, and upon a pulse here, that is a 0 to high pulse here, what happens is shifting is being carried out. Now let's see what happens. This is our data. We are still working on the same data, that is 16 hexadecimal D3, and this is the binary, and we are rotating it 2 places. All right. So notice after the first rotation, we are rotating 2 places. What happens is that this data comes here. This data replaces the data in this position. This data moves to 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 this position. And this data, okay, this data does not vanish, unlike the shift case where the data vanishes. Here this data does not vanish. Okay, what happens is that this data now moves to this position. Okay, and this data shifted 2 places is going to be at this position. Okay, so we have this constant plowback. Okay, and similarly you can now notice that after the second rotation, this data will move here, 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 this data which was plowed back now moves here, and this data will move here, and these 2 zeros are being fed back. Okay, so this data, this one moves to this position, and this one, okay, this 0 moves to this position. And also after the third rotation, we are now going to have this data in this position. This one moves to this position, 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 these 2 zeros moves to this position, okay, because they are 2 bit shift. And notice that these 2, okay, these 2 data, all right, these 2 data, this one now moves to this position, 2 bit right shift, and this 0 move to this position, 2 bit right shift. Okay, so what do you notice after the first 3 rotation? You realize that we are now back to our original data. So this is the data that we started with. So we are now back, and the sequence continues and so on. Okay, and after the 8th shift, we are back again at the initial data. So that is how the shift right functions. Okay, so here we are using the timer to right shift the operations. Next, let's look at the rotate left the operation. So the rotate left operation is the exact opposite of the rotate right. Okay, just that here rotation is being done counterclockwise. Okay, so we rotate in this manner. Okay, unlike the rotate right where rotation is being done in the clockwise. So here rotation is done counterclockwise. Okay, so now this is our data. Okay, this is our D3. All right, we are now rotating left, so we are shifting it to 2 bits. Then this data will move here after 2 bit shift. This will move here after 2 bit shift. This will move here after 2 bit shift. Here after 2. This will move here after 2 bit shift. After 2 bit shift. Okay, and these leading ones, they now become the least significant bits. Okay, because this data after 2 bit shift becomes this data, and this data after 2-bit shift becomes this data. Okay, so the process continues like that, and after the 4th shift, we are back again at our initial. So here we are constantly rotating. You can use it, rotation, operation. You can use it for some LED display. Maybe if you want to display some LEDs in some particular sequence, okay, or want to perform some repeated operation at some particular sequence, then we can use the rotate instruction. Okay, so here we are using the timer. After 5 seconds, okay, so the timer will come on, and after 5 seconds, the timer will go off and the bit will be shifted. So the timer comes on, the bit is shifted. After 5 seconds, the timer is going to be shifting this bit after every 5 seconds. Okay, because after every 5 seconds, what happens is this terminal is going to go low for this timer. So this terminal will go low. So after 5 seconds, it goes low and up again. After 5 seconds, it goes low and up again. And then shifting will constantly be taking place. So let's see a demonstration of that. So this is an example for the shift right operation. So for the shift right operation, this is our data. Okay, so it's similar to the data that we'll be working with. All right. So if I enable this and set it to 1, so you will notice that after every 5 seconds, okay, you will notice the bit will be shifting. Okay, so after 5 seconds, the bit is shifting. Okay, and as it is shifting, right, it is vanishing. So at some moment, it's going to vanish. Okay, so see, the data has vanished, and it will going to stay 0 like that because the data has been updated, and we are carrying out a 2-bit shift. Okay, and now similarly, if we let me just stop this one and set it off. So similarly, if we perform a shift left operation here, set it to 1, so the data will constantly be shifting to the left. Okay, so notice the data is being shifted to the left. Okay, now we are going to have 1. Good. So data is being shifted. After that, it's going to vanish. Okay, just like what we said. Okay, so the data is being shifted. Okay, so notice that we are feeding the data back. All right, so what we are doing is we are feeding the data back to the inputs. All right, so if I just click here and I right click and I go to inspect window, you will see that this is the data here, B, and it should be the same data, or you can just select it and you click on F9. So they are the same data. So when you shift, it's being fed back. When you shift, it's being fed back. Okay. Now let's see the rotate operation. So for the rotate operation, I'm going to activate this. Okay, so rotate operation. Now it has been rotated 1 places. After 5 seconds, rotate again. After 5 seconds, rotation. After 5 seconds, rotate. Good. So now we are back where we started. So after every 3 shifts, we are going to arrive where we started. Okay. So after every 3 shifts, we are going to arrive where we started. And for the rotate left, we are going to activate our inputs. We'll activate our inputs. Let's look at how the rotation takes place. So we're now rotating left. Okay, so the data is constantly being moved to the left. It's constantly being moved to the left. So it's going to be constantly looping. Okay, the data is going to be constantly looping. Okay, and how much shift occurs, okay, is determined by the position of N. Okay, so that was it for this simulation. Okay, so let's go back to the presentation. Okay, so let's review what we studied. So here we have understood what the shift right means. That is, it shifts the data at the input by n number of bits to the right, and the extreme data to the left are being lost. Okay, and the And for shift left it shifts the data at the input by n number of places bit by bit. Okay, and the data at the extreme right are being lost. Okay, so rotation, we use rotation now to rotate the data at the input bit by bit, okay, by some number of places specified by n, and the result is assigned to the output. And finally, the rotate left, we use it to rotate the data at the input to the left bit by bit specified by some number of places n, and the result is being assigned to the output. Okay. Alright, so I think that was it for this video, and in the next video we are going to look on how to work with arrays in PLC applications. Okay, so thank you very much for watching. Please don't forget to subscribe and share this video, and also like the video by giving it a thumbs up. If there's anything on this video that you think you didn't understand, please you can leave me a comment in the comment section below. So thanks again for watching, and I'll see you in the next video.